Hello and welcome! In this lecture, let's add some really nice visuals to our grenade action. Okay, so here is the grenade action so far. I can select it, I can click anywhere, and there you go, the grenade gets thrown, gets there, explodes, and deals damage within a radius. So all of the logic is working perfectly. Now let's just polish up the visuals. We're going to want to add 4 things. First of all, we want a nice explosion VFX when the grenade explodes. Then we want some nice screen shake when that happens. We also want to add a nice trail as the grenade is flying. And finally, we want to throw the grenade within an arc. So let's do all of those. First of all, let's handle the screen shake since that's the simplest one. So let's go here to the grenade projectile. Let's make the nice event. So a public static event handler. Let's call it on any grenade exploded. We're going to make it static so it belongs to the entire class. Then with this, let's just go down here. So here we are exploding the grenade. So when this happens, let's fire off this event. So just question mark and invoke with this and event args.empty. Okay, so we have this event. Now to make the connection, let's reuse our really nice screen shake action script. And over here, let's just listen to it. So go into the grenade projectile and listen to the on any grenade exploded. Let's do this one, make the function. So let's use the light bulb to implement it, okay. Then here we just want to call shake. But now let's take advantage of the intensity. So instead of using the default intensity of 1, let's make the grenade more intense than just one normal shooting. So over here, let's put 5F. Alright, so that's it. Let's test. So here we are, select the grenade, throw, and gets there. Boom, there you go. Nice screen shake. Okay, super simple and already looks quite a bit better. Now, next up, let's handle some explosion particles. So first, let's make that VFX. We can actually start from the bullet hit VFX. So let's duplicate this one. Call the grenade explode VFX. And instead of opening the prefab, because over here it works, but remember that inside the prefab we don't have any post-processing, so let's not play around with it here. Instead, let's go into our scene view, and over here let's just drop it somewhere. So just like this, then we can see. Okay. Now while we're testing, let's do the same thing that we did. So let's enable looping again, just for testing. So now it's constantly happening, so every second we can see it. Alright, so let's make this a nice explosion. Let's make it a bit more intense than this one. So first, let's go into the shape. Over here, let's leave it a sphere, okay, but for the radius, instead of 0.2, let's put it quite a lot bigger. So maybe 2, quite a bigger sphere, alright. Then let's also spawn tons more particles. So instead of just 30, let's put it at 200. So that's already quite a bit, but then let's also make it 2 cycles with an interval of 0.050. So spawns 200, then 200 right after. Okay, so that's already quite a nice amount of particles. Then let's go up here for the start speed and let's make them move quite a bit faster. So let's put it between 3 and 10. So there you go, now they move outside quite a bit more. Next up for the size, let's also make it a bit bigger, so between 0.2 and 0.6. Okay, so there it is, much bigger explosion. We can also put the game view side by side just so we don't see the selection widget. So there you go, that's starting to look like a proper explosion. Now let's also add some nice trails. So on the inspector, let's go down to find the trails. Let's toggle this checkbox. Then this requires a material, so that's on the renderer. We need to assign the trail renderer. For that, let's make a material for both the trail as well as this. So let's duplicate the bullet projectile, call the grenade explosion, and on the grenade exploded VFX, let's assign this one. So down here on the render, let's use grenade explosion on both the regular material as well as the trail material. However, for this one, let's make it less yellow and more white. So on the base map, put it in white. And on the emission map, maybe a bit more like this. Okay, like this. Now let's just play around with the trail a bit more. So over here on the trail settings, let's make them last not as long, not 1 second. So let's say just 0.1. Okay, that's starting to look much better. Then for the vertex, since they move pretty quickly, let's put this smaller, so 0.01. And also for the width over the trail, right now the width is a bit way too big, so let's put it just 0.1. Alright, so here we've got a really nice grenade explosion effect. Now of course, since we're changing these settings on the scene view, make sure to go up here and go into overrides, and let's apply the overrides in order to save the grenade explode VFX. And of course, the thing that I forgot over here on looping, let's untick this and once again save the overrides. Okay, that's it. Everything else should already be correct. Just make sure the stop action is also on destroy. Okay, so everything is correct. Let's get rid of this from the scene view. All right. Now let's spawn this. We do that over here on the grenade projectile. So let's add that reference. So a serialized field. private transform for the grenade explode VFX prefab. And here in the editor, let's drag that reference. So we go into the grenade projectile and let's drag the grenade explode VFX. Okay. Then here, when the grenade explodes, so when we've got our destroy, let's just call instantiate. Let's instantiate the grenade explode VFX. And for the spawn position, let's use the target position and quaternion.identity. However, the target position, that one is right on the floor. So let's actually lift it up a bit. So let's add a vector3.up multiplied by, let's say, just 1 unit. Okay, so with this, let's test. So here we are, select the grenade, let's fire it in there and get there. Boom, there you go. A really nice, really pleasant explosion. Okay, so far so good. Now let's add a trail to the grenade. For this one, let's do it just like the bullet trail. So let's actually go inside the bullet projectile. Over here we have the trail. So let's just right click, copy this one. Then let's go into the grenade projectile and over here right click and let's paste as child. So yep, there's the trail. Then let's just change some things. So for the max width, let's put it at 0.1 and for time, let's a bit longer, so just 0.2. And finally for the material, let's use a different material. Let's duplicate the bullet projectile and call this one the grenade trail. Let's go into the trail and let's assign it. So assign the grenade trail. However, over here, instead of going with these, let's go with a pure white. And for the emission map, let's also go with pure white and just a little bit of intensity. So maybe just 2. Okay. And finally, over here on the trail, let's just verify that we do have auto destruct. Okay, great. So we're going to do this just like we did with the bullet. Now let's save the prefab. Let's go outside. And now on the grenade projectile script, over here, let's add another reference. So another serialized field of type trail render. Call it the trail render. Then when this explodes, so down here, when we spawn the grenade explode prefab, let's go into this one and just like we did, let's set the transform.parent and set it to null. Again, since we enabled auto destroy, this is going to clean itself up automatically. Okay, so let's go into the editor. Let's go inside the grenade projectile prefab and just drag the reference to the trail. Okay, so let's save the prefab and let's test. So here we are, select the grenade, let's throw it over there, and there you go, we've got a nice trail as the grenade is flying. All right, great. So the final task, let's make the grenade be thrown in an arc. Now for that, you might think to make an animation. Technically that would work, however, animations are static whilst the grenade is pretty dynamic. So the grenade can be thrown in almost any direction, any distance. If we did some animations, we would need a separate animation for every single one of these throw positions. That is obviously way too much work, so let's do it dynamically. For that, let's go here to the grenade projectile script. And what we basically want to do is still do exactly the same XZ movement. However, we want to apply a nice arc on the Y position. And for that, what we're going to use is a really awesome Unity tool called Animation Curves. So let's make it up here. Let's make a serialized field, private of type animation curve, and call it the arc Y animation curve. Now if we see in the editor, and we select the grenade projectile, there we've got a curve, and if we click on it, yep, we see this nice curve window. So over here, now we can make a curve of any shape we want. So for example, down here we've got some presets. Let's start off with this horizontal one, and let's leave the left point over in there, and let's say the curve really just goes down like this. Also, you can position it in any way you want, or you can right click, go into edit key, and place it exactly where you want. So for this one, let's place it on time of 1 with a value of 0. And also if you select it, then you've got these handles, so you can play around and make the curve pretty much have whatever shape you want. Alright, so here we've got something that starts off high and drops low. Also make sure to use normalized values for both the X and the Y axes. This is technically not necessary, you can use any values you want, but making it normalized is going to make it super easy to handle it. So down here we see the X axis goes between 0 and 1, and for the Y, same thing between 0 and 1. Alright, so this is our nice curve. Now here in the code, we've got our animation curve. And then here, when we move, we're going to want to get the normalized distance towards the target. So in order to calculate the normalized distance, we also need to know the total. So let's make a private float for the total distance. And for the total distance, let's calculate it here on the setup. So the total distance will be vector3.distance between this transform.position and the target position. Then, like I said, let's also handle the regular movement on the XZ, and we're only going to apply it on the Y axis. So let's keep a separate vector3 just to keep our XZ position. So let's make a private vector3 for the position XZ. Then down here on our setup function, let's define our position xz equals this transform dot position, and let's make sure that we have a y of 0. And when calculating distance, let's use this one as well. All right, so we have these two nice values. Then let's go here to our movement. When we move, instead of moving the transform dot position directly, let's only work with the position xz. So let's also work just with this one. We never touch the transform dot position. We do this, then let's get the current distance. So a float for the distance, and we're going to do a vector3 dot distance between the position xz and the target position. That gives us the current distance. So then we can calculate the distance normalized, and that is just going to be the current distance divided by the total distance. However, like this, we're actually going to end up with it inverted. So this is calculating the distance from the current position to the target. So as it approaches, then basically this one is going to become smaller. So it's going to start off at the total distance and slowly become smaller. Whereas for the distance normalized, what we want is the opposite. So we want the value to start off at 0, and as it gets closer to the target, we want to reach 1. So like I said, this is inverted. We can simply just do 1 minus in order to invert it. Okay, so with this, we have our nice distance normalized value. Now with this, we can apply it to the curve. So we can go into the arc y animation curve, and we call the function evaluate. And this one takes a value which is going to be the position on the x-axis, which in this case is our distance normalized. All right, so this is a float for the position y. Then we can just set the transform dot position, and we're going to set it to this position xz.x. Then we use the position y, and then the position xz.z. Okay, so that's it. So basically our logic is only moving on the xz axis, and then we're grabbing the y directly from the animation curve. So again, if we look on the animation curve, down here we've got the x-axis. So this is where that evaluate function is going to grab the values from. So as we start off on this normalize of 0, it's going to grab the position on the x of 0. So it's going to grab this value up here. And then as it moves forward, then the grenade will essentially start off high and then slowly go down. Okay, so let's see. All right, here we are. Let's choose grenade, go there. And there you go, it does do an arc. So the grenade starts off at a unit of 1 and then slowly comes down to the floor. Okay, great, so it does work. Now let's make it arc a bit higher than just 1 unit. So for this we have two options. We can either do it over here on the curve itself, so you can grab this point and put it as high as you want. So that's one approach. Or we can leave this value as pretty much normalized and then just do some math whilst inside the code. So let's do that. Over here, when you grab the position xy, let's calculate a float for the max height, and let's say something like 3 units. Then when we grab the position y, we evaluate the curve and then just multiply by this max height. So now if we test, here we are, let's throw the grenade, and yep, there you go, now it starts off much higher. Although do note how it's still following the graph. So let's unmaximize this. And on the projectile, over here, like I said, you can make any curve you want. So for example, let's make a curve at a point here, so go down, then maybe go up, then go down again, then up again, so a really weird shape. And if we test this, so here if I fire a grenade, yep, there you go, it does that weird shape. So as you can see, by playing with the curve, you can really get any shape you want. So this would look really interesting for some kind of sci-fi spell effect. But in our case, it's meant to be a bit more realistic, so let's change that. So on the curve, instead of this, let's get rid of these other keys. So that one, that one, that one, and that one. And for the starting point, let's actually start off at a bit more than half height, so maybe on 0.6. And once again, we can edit keys if we want to make sure we use the proper values. So on a time of 0, value of 0.6. Then let's double click to add a new point, and let's add a point somewhere above 1. So the grenade starts off and goes high, then gets high, then falls down in the end. Okay, so let's see this. So this unit is actually out of action, so let's use this one, throw grenade, go there, and there you go. All right, so it starts like that, goes up and then down. Okay, great. So this is working. However, the issue is that the max distance is fixed. So it looks pretty good if we're firing off a grenade this far. However, if we try doing it this close, if we do, yep, there you go, now it looks a bit weird. So let's basically calculate the max height depending on the distance. So here, instead of defining a fixed value for the max height, let's just grab the total distance and let's divide it by some amount. So basically the max height will be dependent on the total distance. Okay, so let's test. So here we are, and if I fire the grenade far away, yep, there you go, it looks pretty good. But if I fire close, yep, there you go, now it no longer goes insanely high. Alright, great. So with this, our grenade is already looking pretty great. Now let's change one more tiny thing. So over here you see all of the enemies right next to one another. And if I kill them all at the same time with one grenade, so if I throw this grenade, there you go, blows up, yep, they all die. As you can see, it worked, they spawned the ragdolls, but the ragdolls all worked exactly the same. It looks very strange because they all fell in exactly the same manner. Like I mentioned, you can make some more complex logic to take into account where the damage came from. So you could say that the grenade exploded here, so for this one apply a ragdoll force going in this direction, for this one that direction, and so on. You could do that. Or something that is much simpler is to just add a tiny bit of randomness. So if you go here into the unit ragdoll script, over here we're applying an explosion, and we're applying an explosion directly on the transform.position, which is right at the feet of this character. So in here, let's just add a random direction. So a vector3, call it random dir, and we just do a new vector3. And here let's do random.range, a range between, let's say just -1 and +1. Then on the y, let's not touch that one. And finally, also same thing, random.range between -1 and +1. Also here, make sure you include the f in order to make sure that this function is using the float variant, because if you don't, then this is going to use the int variant, and if so, then the only possible values are -1 or 0. So do make sure you include the f, so we've got all of the possible values between these two. Okay, so that's the random direction. Then on the position, we just add this. Alright, so that should add a tiny bit more randomness. Let's see. So here we are, let's throw some grenades. So throw them in there. Okay, just one more, throw, and boom, there you go. And now they do move in different directions. Okay, great. So now it feels much more natural. Alright, so in these past two lectures, we implemented a really nice grenade action with a really awesome visual. It has an area of effect, so unlike the bullets, it can deal damage to multiple units. And now that we have an action that deals AoE damage, it would be fun to add some destructible objects, so let's do that in the next lecture.